Airplay, what is this?
It's a presentation. I'm not sharing my screen right now.
You're not.
Oh, this is Mariah's screen.
That's why.
My screen.
Yeah, she took it.
Look like Todd.
Welcome to the Utah Go user group. I appreciate you all coming. I know you could be anywhere on a Tuesday night. You chose to be with us here. I really appreciate that. And we work hard to try to make it worth your time. So I appreciate you coming. We have a couple of things. We'd love you to join our Slack if you haven't joined already.
That link is on meetup on the group homepage.
Did you fix it?
No, not I just muted it. You muted it, but
It was working. I played Mariah.
I'm kidding.
Yeah, join that. We get lots of good discussions about Go. We get lots of good discussions about Kubernetes, other cloud native things. Trying to build up a pretty good community in the area, so it's a good place to get on, ask questions. Undead Ops was just pinging me earlier today about some questions about how to automate SQL migrations and things like that. So it's a fun place to just share and collaborate. And what's nice about the people that come to this meetup is it's pretty open. Like we'll share our architectures, our infrastructure, the way we do things. And there's a lot of companies, a lot of people here that are at companies that are scaling or growing really quickly. So it's exciting and it's a good place to ask questions. I'll let Mariah talk about the conference that she's running with Derek. Oh, yeah. Derek, we'll let Derek talk about it because he's got to go pee.
And I talked
Like officially. Yeah. So we are hosting a regional Go conference for Utah and Colorado, kind of this western area. So on May the 7th, there is a workshop. And then on the 8th, we'll have 2 tracks, a beginner and kind of more advanced track. We're hoping to have ticket sales available in the next couple weeks. And if you haven't already listened to the talk, we prefer to have a lot more local people speaking there rather than flying in people from all over, just to keep it local, show off the talent that we have here.
I've seen some of the submissions and they look pretty impressive. Yeah.
We have quite a few impressive submissions.
Yeah, so that's
So
exciting.
we're also very open for like first-time speakers. And like Derek said, we part of our goal was not only to have a regional conference that is for the people in this area. So we want the people in this area to be the ones speaking. We want them to be really accessible for people to attend and just kind of grow the community we've already started with our meetups.
Then we just open it up to anybody out there that wants to announce that they're hiring or anything else. Is there anyone that wants to raise their hand and say that something at all?
Yeah, I have a part-time consulting opportunity if somebody's interested. Go, also browser automation, so a little JavaScript would also be useful. Could be useful for someone who isn't that knowledge or isn't that experienced in Go. It's pretty much already set up. So if you know somebody, talk to me afterwards.
Yeah.
And I work for a 3D software company downtown Salt Lake City, and we are looking for Golang developers that we're basically building all of our entire web infrastructure on a Google App Engine on Go. And yeah, so we're actively looking for anybody that might be interested.
What's it called?
Your company, what's the name?
Oh, Taffy.
Taffy. It's yummy. Anybody else? All right, well, I'm going to go ahead and turn the time over to our 2 speakers. We're going to start out with Todd. We recently, if you weren't a part of it, there's this really cool coding competition that happens every year during the holidays called the Advent of Code. And we had kind of a competition going here for any people that could implement, you get points based on how fast you solve the problem. And so we have a little competition to say, you know, who can get the most points in Go-only solutions, which you might at face value, you're like, well, that's not that big a deal, but it actually is a big deal to do some of these in a typed language. It's like a ton more work. So and speaking of which, I'm gonna go get the prizes upstairs. I got some Amazon gift cards for the top 3 winners, so I'll go get those. So congratulations to those. I have to still go do some audits on the, I'm just gonna do some spot checks to make sure they were actually done in Go. And no one was cheating, but it's pretty much, I'm gonna trust you because I'm not gonna look at every solution.
2 out of the 3 are presenting, so.
And 2 out of the 3 are you presenting, so you better not be cheating, right? Todd had this idea of sharing kind of what he learned about the language. Todd, you don't program Go professionally, right? This is kind of your first foray.
It's my first actual programming of anything real.
That's so cool. So he used this opportunity to learn Go, and he wants to talk about, he's an experienced programmer, so it's not like it's his first language. But so he can talk to you, he's going to talk to you about, I think, some of the things he learned. Carson is a senior DevOps engineer here at Weave, was formerly at Domo, and he is programmed in Go before, but he wanted to do this opportunity to like really master Go as well. So he's going to talk about some of the things he learned as well after Todd. So we'll go ahead and turn the time over to Todd. Thanks for coming.
As stated, I do have some experience in Go, but only at Go. Other than Go, I've been programming for about 24 years. So, noob. Just kidding. Just getting my feet wet, you know. Really liking the industry, you know, hoping the future's good. Which screen? That's the question.
Yes.
There's apparently options. Hey. Okay, so yeah. So I learned to Go for Advent of Code. Feel free to judge. I don't care. My code is terrible. I learned a lot about Go, idiomatic Go, and how to approach it during this. So I didn't go back and refactor any of it either. For good or ill. So let's see. First of all, I am mostly a Python user. I work in C#, but mostly in Xamarin Forms, which isn't really terribly C#ish. It's more XAML-ish. I know a lot of other languages. I just haven't worked on them in a long time. There's a few of them I won't even put on my resume anymore because I don't want to work in them anymore. COBOL is one of them. I have been paid professionally to write COBOL. I don't look that old, but there are still modern companies that use it. So
COBOL is the highest paid
Was that
language.
Was that on the survey? On the Stack Overflow survey?
if you want to make money, you can write in COBOL. At what
That
cost?
is one source that is information from a podcast.
All right.
So just cost your soul.
Just letting you know, you could be making more money and
Yes.
lose your soul.
I'm not a fan of any language. I hate them all, just some more than others. Java.
Yes.
My opinion is not the end all be all. It's not an authority. I'm not like an inventor of languages. I'm not paid by a professional university to like study this stuff. I just have opinions. So yeah, don't be offended, Carson. And so again, this is only a month in. Please do not judge my experience with Go. You can go to the Utah Forge and see some of the questions I asked about Go and some of my learnings along the way as well. And you can see just how noobish I am. We'll see how I feel about that after, like, say, a year of Go or something, assuming I do more with it, which I plan to. So that said, everything I'm about to nag on Go for is also not going to put it outside of my list. I would list it on my resume if I had a little more experience with it. It is near the top of my list of tools I will probably reach for in the future. So if you want to pay me enough to work on Go projects, I would also do that as well. And I think that's endorsement enough, all right? So yeah, please don't vilify me at all. Advent of Code, I have done it every year since it existed. It's been about 4 years now, maybe 5, I don't know. I get about 6 days in and then I'm done. The competition here has sort of helped. Mostly I think it was the competition with my son, who is like a serious programmer now, and like now that we're all a part of this community is like, well, let's be driven and do stuff. And I think that helped a lot. It motivated me to actually finish all 25 days. I did understand all the code that I used that is in my repo, but in my repo you will see some comments that says, shamefully stolen from Jacob Puff or heavily influenced by this code. My rules were that I could copy his code because I created him, so technically I wrote that code. But as apparently discussed, I only half wrote that code or something. So int code is a little VM computer that you write, and I really enjoyed those problems, and we'll talk more about those a little bit. I'm sure Carson will talk more than I will. And every year I stop on like the mathy ones that you really have to know, like some obscure thing that isn't really used in like your common programming vernacular. Like in games, I understand what all of the different vector math stuff that you want in linear algebra and systems of equations and stuff, but I don't use that anymore because I'm not a teenager and I left the games industry way, way long ago. I don't use it anymore. So anytime I have to go back and look at it and say like the Moon project in this year's Advent of Code, I just have to look all that up if I'm even going to do it, and it never motivates me. This year we did. Honestly, like it's improved every year, and this is the best year I've experienced with it. Hopefully next year this inspires you to participate if you didn't this year, because it is fun and it's a great opportunity to learn a new language like Go. So day one, you're given a list of inputs of just numbers, and you take that, and those are modules for your spaceship that you need to calculate the fuel for that you will need to get to space. So every day is divided into two parts. This is not the full solution. I will not have any of the full solutions in my stuff. Not enough room, and if there was, you couldn't read it anyway. So this is like the intro. This is like the easiest way to judge me, I guess. It's all in one file, and my main method just has a day input that it takes from your args, and a switch that depending on the day will go to day 1 or day 12 or whatever, based on your input. So simple, straightforward, no modules or anything. I did learn about modules afterwards, but I never went and retrofitted because it didn't seem worth it. But day 1, you have to take this for part 1 and calculate the fuel. And then part 2, which every day has 2 parts, you get the second part after you're done and have solved the first part. And day 2 is usually kind of a kick in the shins to say you did it wrong. And day 1 was no exception. It was, hey, I realized that you just added that all together and just ran the fuel calculation function against it, and that's how you got the right answer. But the right answer is wrong because you didn't calculate the fuel that you need for your fuel, because it's heavy and you need to fuel your fuel. Yo, dog. So this is the first day that I used file IO because it was day 1, and file IO was really easy. Congratulations, Go. You've made file IO really easy. Some languages don't, and I'm just really glad that this was only like 5 lines of code. Getting text out of it, also really easy. This is where I learned string convert, parse int. I don't know how you pronounce that because I've only read it online.
Stir curve. It's called foot, so I wouldn't put it past him to call this stir curve.
All right. So you can see, like, that's pretty much my iteration over the entire file, and it fits on this slide. So that's pretty impressive. I was pleased with day 1. It only took 10 minutes. And again, that's with no experience with Go. I did set up my environment beforehand, but other than writing a hello world and going through the tour of Go the day before, I did nothing with Go. So yeah, day 1 was pretty good. The scanner, I will say, is very Java-esque, but it's very lightweight. So that was weird to me. Felt wrong. Day 2. This is what I started with in day 2. This is the first int comp, where you're writing a VM and you have like 4 opcodes that you have to write for, and all the data is in one just giant array. You'll notice that I have a slice that's raw put there, and that's fine, I guess. I don't know. You get the input file exactly like that, so I literally copied and pasted it into my code, which means that nobody else can use my code. So there's that. All I did was learn how to do the copy, and that comes in a little later, where part 2, I had to change to look like, or part 2 I had to change to make a copy because I had to run it multiple times with different inputs to find out a thing. But later on, I learned a valuable lesson that you could pass in functions, because right now I'm doing all the input and output that this computer takes. It's just you give it a number, you take out a number. That's its input and output. You convert that to types all the time, like characters or whatever, but it's just, here's an integer. And the way that worked initially was I just had it hard-coded in the parser. And I found a lot of utility about day 6 or 8, because every other day was an int-cop problem, that you can just pass in functions. And so I generated functions, and I was like, all right, here's your input handler, or gatherer as I called it, because it gathers input. And here's your output handler, which is just print it in this case, because that's all it needs to do. It just gives you a number if you've written your code correctly. Day 8 was where things got interesting. Day 8 was where I decided that I would have quit had it been any other day. Oh, no. This was not. No. Day 10 is. We'll get that. Day 8 was a multi-layered 3-state bitmap. So you got like 100 layers of just integers, 0, 1, 2, and you literally have to say like 0 is transparent or black or whatever. There's black, white, and transparent. Those are the 3 states. You put those layers on top of each other and you see, hey, what is my image like? And then you literally have to print out your image. This was the first day where we totally diverged between my son and I sitting in my office, our office. It's my office, I own it, okay?
Fine, be that way.
Get out of my house. And so we totally diverged. He actually like downloaded an image processing library and just splat out a whole like PNG, and then it was way too small because pixels. And so he had to like expand it and like make it bigger, etc. And that was awesome. And then he didn't do that. It's still totally small, he just zoomed in. It seemed easier. But I really enjoyed that Go, switch statements in Go, thank you. As a Python person, I don't have switch statements. So it was very nice to see that. It's very easy to get the for loops. There's a variety of them. This is also the first day that I ran into integers and the difference between an int and an int64. This is a thing I run into in every type language, and I hate it. What is the difference between an int and an int64? Maybe nothing. Maybe everything. Who knows? Why do you have an int32 and an int64? Why not an int16? Why not an int128? Why not an int256? You know, why not? Well, the underlying no. We wanted to be typed, and then we didn't. And this is always the case in every type language is you end up with these edge cases, and you can't escape it because of language theory, and I know that. And I always run into that, and I hate it. And the total opposite is even worse, PHP. So it's not like I have like a middle ground where I really like am advocating. I'm just saying I ran into in the standard library a whole bunch of things that returned ints and a whole bunch of things that returned int64s or int32s. Or it was an int64, but you determined how many bits there were. Like our int parts in the but beyond that, it was a joy to behold working with ints or int64. It was really easy to switch out. I just never went back and refactored the int comp to work with ints instead of int64s. This is where I stuck. This is my first nopel. I just noped right out of it and said, nope, I'm going to bed instead. Because we did this at 10 p.m. when it was released every evening, and stayed up. And he actually stayed up and did it for about, what, 3 hours, I would say?
It was very late when I went to bed.
Yeah.
No longer have a sleep schedule.
Well, you probably explain what the problem is, right? Like,
So,
You're a developer.
So the fun bit here is you are given basically a field map. It's a 2D grid, right? And each of those hashes are asteroids. And you, for part 1, have to figure out what is the best asteroid to be on, because which asteroid can see the most asteroids. And you have to use some mathy stuff to do that. And I know what the mathy stuff is. I know that it's going to be something with like trigonometry, and I'm going to have to do some sort of like tangent arc or something around the whole thing and do all the slopes and configs. I'm not all about that, especially not at 10:30 p.m. after a few beers. It's not really my thing. So I went to bed, but he was all about doing this, and I woke up and he was like, I did part 1, then part 2, I didn't know enough. Because part 2 is, okay, all right. You found the one that can see the most. You can actually do that part without any of the mathy stuff, and he did. Now, fire a laser from that one, starting straight up, north, I guess in this, straight up, and every single time you fire it, the first asteroid that you hit explodes. It goes away. But there are other asteroids behind that. You're going to leave those alone and move on to the next one you can see, and you're going to go all the way around.
To spin.
And then you're going to go around again and again and do that repeatedly until all the asteroids are dead.
No,
Like the Death Blossom.
it's the 200th
Yes.
one.
Which one's the
What?
It's the 200th one.
Yes. You have to do it until it's dead, but you have to calculate which one is the 200th one, so you can't just say like, well, how long would it take or how many rotations or whatever. It's what's the 200th asteroid to kill, what's its X and Y. And then you have to do like some calculation that ends up being like X and Y listed as one number. So that was kind of my first no. It did end up being pretty easy. It's a lot, if you look in the code of anybody's code really, it's actually quite short, but it did require math and math equations that I didn't know, and we just ended up looking at other people's code. That was kind of my rule. Don't look at anybody else's Go code, because I'm trying to learn Go. I basically targeted either Python or JavaScript because I know what they are, and I know they're a totally different thinking paradigm. I have to adapt them over. And honestly, most of the initial answers in these competitions are all in Python for whatever reason. There's a couple that are in like J. I don't know why, but whatever. And so you can find really good ones, but if you're like looking at a whole bunch of list comprehensions from Python, converting that to Go is difficult. It's not just for loop within for loop, it ends up being weird. So I learned a lot about the constructs of Go that way, and including on this one where we ended up looking at somebody else's arctan2 function that we just basically re-implemented, and in slightly different ways, and it was good. So I'm not skipping. I'm not skipping because this is the short version. So nobody be offended. I like Go, okay? But while it is lightweight, it is, I mean, it computes fast, obviously, duh. I really like the concurrency. I didn't get into where I used concurrency. I did use that on one problem in this particular exercise, I guess, I don't know, experience. The biggest thing that I found was that the community is good, and that's critical for a language to me. That's why I'm not a Rubyist, because back in the heyday of Ruby on Rails, the Rails community was not exactly very welcoming. If you ever sat on IRC and talked to Rails people, it was not a friendly experience, and the Go people so far are really good. Maybe that's a Utah thing, I don't know. But everybody I talk to, and I'm not just in this community, really friendly, really helpful, willing to talk about things, including dumb questions like, do we use ints or Int64s? Well, so congratulations, you're all very good as members of this community. Where are generics? I don't know. It's been 10 years. I feel like generics should be there. It's a strong language. It kind of helps. This is not news to a lot of people. I will say that also it is very apparent that Google does not care about like everybody else's use case. They're not trying to add features to the language to solve like Amazon's problems or anything. For good or ill, that's not like a terrible thing unless you're me, who is not Google. And then like you don't get necessarily features in the language or tooling or whatever that benefits me. So I think the community is making up for that, and that's good. It's very apparent that Rob Pike thinks I can't program. He said as much. That does bleed into the language a bit, and I feel like somebody's hand-holding me a little bit. I tried to think of a serious use case for that wouldn't be like egregious, and I didn't find one that would fit a mixed audience, so I didn't go with one. But there's plenty that other people have opinions on, and it's worth a debate. It's worth a discussion. I don't think it's a killer for Go though. Like I think it's the same problem that you have in like Python, where well we think you can only handle English, so we took away these operators or whatever. But the tooling makes up for that a lot as well. So you can get good code generators and stuff. I think that there's a lot of room to improve tooling. I switched between Visual Studio Code and Golang just to try to get both experiences. And as far as like syntax highlighting, code hinting, things like that, spot on, everything's there. As far as like package management, okay, we're kind of beginning there, I guess, for good or ill. And I don't know, I don't know how I feel about the composition versus configuration argument. I know where I sit on it in the Java world, but Go is sort of doing some of it in some areas and not in others. The example here, capital letter exports. Like who decided that was the way and that was the important thing? I don't know. I don't have an opinion on that, but it just seems like, wait a minute, why can't I do what I want? Being dictated to is usually off-putting to me, open source. So yeah, so that's my way there. Yeah, you can see me as the angsty teen that I am over programming languages, and that's fine. My things that I'm going to dive into next are usually webby things, and the thing that I hate most in type strict languages is dynamically loaded structured data, like JSON or XML or things like that. Java is terrible at this. It's just terrible at this. C# also terrible, just not in the same ways. And I have no idea how it's done in Go. I'm going to find out. And hopefully it's not all just empty interface stuff everywhere.
JSON to go. That's how it's.
Yeah, you have to convert and generate it.
Those JSON to go.net or whatever it is, like that.
Yeah, but that's strongly typing it beforehand. I don't know what's coming in. How do I dynamically? It's going to be a weird reflection, isn't it?
It's gonna be a weird reflection. You don't want to do it.
All right. So not a strong start. Thank you.
Map string interface.
See. So we're going to build.
You don't know what's coming in. Map string interface.
Basically, that's going to be like how I'm going to approach everything in like my Python thinking. And I don't want to do that, but yes, you're probably correct that I'll probably lean that way a lot.
Well, if you're not talking to Satan on the other end and the JSON's like reliable, there's even if like you have
JSON's
to
never
determine
reliable.
I was going to say it.
type.
Did you say not talking to Satan?
Yeah.
We talked to a lot of Satans.
A lot of internal.
Been on the
other
internet.
teams.
I live in the real world, so
Distance.
database stuff. I took a look, like a quick Google for like an hour. It seems kind of sane, but I haven't done it, so I want to dive more into that. Again, very webby. I want to figure out plugins. Caddy 2, we had a talk last month.
December.
Yeah, okay. And they have a plugin system that I really kind of was interested in. I want to look into that and see like how easy is that to port around. There are languages that I just can't, but I come from back in like the C++ days when I could just do like DLLs or .sos and like load things dynamically. And I kind of miss that in a lot of things that I do. So we'll see where Go fits on that. And then, see where I go from there. Do I want to do this all the time, or do I just want to do like a weekend project kind of thing? And I don't know what the answer is going to be. Maybe I'll end up being like, all right, Go is cool, but I'm not going to do it for a living or something, or I'm not going to take it as a serious project. We'll see. I don't know. Any questions? Thank you for being a dynamic audience, of course, and weighing in on things as I go. That was helpful.
You get to use channels at all?
I did get to use channels twice, in fact, with the concurrency one. And there was one where I just used it as like a final signal so that I could just spin something off and then just wait. And they're easy. They're just so easy. It's very nice. Again, I'm in Python, so like async await is just a nightmare to think about and read and look at. You can yield, and I will hate you for it. And so, yeah, if you want to talk more like online, want to write me a scathing email about Go and how it's great or whatever, then feel free to reach out. I'm happy to ignore you. And, yeah, thank you again. So. Carson, you're up. You want a clicker?
I brought mine, and then I forgot to unplug the USB Carson mic. So I have a useless clicker, which sounds like a personal problem, and I don't really want to talk about it. So I'm going to take.
Yeah, that's because you didn't know what channels were, and you started at 1:30 in the morning.
I know.
Let's just take it up for it.
I'm
Let's just take it up for it.
It came out earlier today. No, it's not. Hold on. No, it's not even. It'll be a lot cleaner if I do it this way. Did we unplug it at the other end as well?
That's what I was thinking.
Let me just restart this real quick. If not, I'll join the Zoom and we'll do it that way. But I had it working earlier, but didn't quite reach for Todd's laptop with the USB on the wrong side. Apparently there's a wrong side.
There's a wrong side.
Yeah, it's the side yours is on.
Oof. I feel it. I feel it in my person.
Just have one on both sides. Then you don't have this problem.
That's what Mac does.
I don't want to like.
Do you want to be like Mac?
Or there's only the HDMI and the network cable that go into here, right? Not like we didn't unplug and miss. I didn't miss something.
Carson, there's a little box with a green light on it that's on the inside.
Oh yeah, it's blue.
Is the light on?
It is on.
It's blue. Not green.
Well, it's still not that box.
Oh, you mean
Inside the podium.
inside the thing? The link?
This
Yes.
reminds me of your old.
You know what? That HDMI was loose. There we go. There was a loose cable.
I didn't do that. But that's your solution.
It was like, had certain dongles that like, at certain sides of the computer.
Usually doesn't have a problem.
Well, I usually get here early and set up and.
We always play Linux when it's in this office.
First thing we jump to.
Yep. And that's, you know, that's fair. It's always Linux's fault. In fact, we should switch to Windows servers.
We do have a Windows.
Okay, there you go. It turns out if you plug in your cable all the way, it works, which is fun. Okay, so we were talking about Go stuff and learning Go, and I realized I have like documentation of my first Go thing that I ever did. Because the reason I'm a sysadmin DevOps guy at heart, and I only learned Go because all of my favorite tools like Docker and Kubernetes were written in Go, and I wanted to add stuff to them. So I literally learned Go, and my first thing I ever did was add this Mongo feature into this Docker auth plugin that is a auth layer in front of a regular Docker registry. So I actually have like proof of my first Go commit that I ever did, which was to a real project, which is pretty cool. We use this to the day I left at Domo.
Are you Roger?
No, I'm Carsonoid. He merged it, come on.
He screwed you out of your credit.
I know, well, it's half in there. No, there's a merge, there's my commit, this is just. Anyway, so like Clint said, my name is Carson, I work here at We, formerly at Domo. I learned Go to do stuff like that because I was doing a lot in the cloud native space, and that's like just basically Go, de facto Go. In fact, I'm always surprised when I work on something and I found out it's not Go. I'm a little shocked, like, yeah. So I have a bunch of different opinions. I'm actually using the advent of code more to jump off some like weird Go minutia that I learned, because I've done a lot of Go. I mean, I've got a full open source project from scratch that I wrote that is a Kubernetes pod scheduler that's all in Go. I've done a lot with the Kubernetes API and all this stuff, but I haven't done a lot of low-level Go work before. And advent of code is a lot of low-level Go work, including lots and lots of parsing of input. So a lot of my takeaways are based around that. Day one, I'll cover again a little bit. Again, in day one, you have a file that's just a list of integers separated by new lines, and you parse them, you run a function against every single line, and you calculate the result. And I highlight the take the mass, divide by 3, round down, and subtract 2, because I don't know a lot of low-level Go stuff. I mostly glue stuff together with it. And I did a bunch of gross stuff initially because I didn't understand default Go behaviors. So day one's a really, really easy thing for everyone to grok. It's literally like, you don't have to do this ugly thing that I'm doing in the middle where, we find 298 divided by 3 isn't even. So I did a very Pythonic thing here in the middle, which is like float it and then turn it into an integer. And then somebody in the Slack said, yeah, that's just what Go does by default. So not like the most complicated thing that I learned, but it was neat. So Go does rounding down by default. The day two, again, is encode. So this is another example of what the encode computer looks like. I will kind of go over, like Todd said, this is really cool. I have a couple other examples of where I think it started to get more complicated and some of the features of Go help me keep track of things. To kind of go over a little bit how this worked, just deeper on what Todd said. The very first line in an encode program is an instruction code. In this case, 1 is for add. And then the next 2 integers are, find the value at a specific position, add it to another value at a specific position, and put the result in another position. It gets more complicated later, but as I looked at this, and I didn't do what Todd did, I actually read all of my input from files. It helped me a lot because I was able to make kind of fake text files and pull in all sorts of different, run different kinds of code without having to modify my code. And when I saw this, I realized really quickly that lines could get really, really long, right? Like this is a single line and it could get really long. And I'd heard something about scanners having a line length limit. And so I took a second to actually learn the difference between scanners and readers, which has been really useful. So if you don't know, here's an example of a scanner where I'm exploiting a problem with the default scanner, which is what Todd used, right? And you can most of the time get away with this, but what we're doing is doing this really ugly way of making a file for the scanner to read. We're making basically 1, 2, 3, and then a 4 repeated enough times to just barely go outside the default line length limit for a scanner, and then do 5 and 6. And scanners, like Todd said, are really nice because they're super clean. They're easy to use. They read really well because you just initiate the scanner and then you loop through the scans and you get the text out. They're also more efficient in a lot of ways. But if you're not careful, you might silently fail out if you get a line that's too long. And so I actually have a place that shows what this looks like. So if we run that same code, click in.
Maybe.
Maybe not. What the heck's going on there? Oh, there we go. So this is what happens if you, it gets to 1, 2, and 3, and as soon as it hits that line 4, that's too long for the default scan length, it just crashes out. And if you didn't print out the scanner error or check the error, then you wouldn't even know that you'd hit a problem. So it's not as nice as a reader for telling you when you're hitting an issue, because it'll just kind of silently fail, 1, 2, 3. The scanner is done. It's exited out because it had an error, but if you don't explicitly look for that, you might just miss it. I didn't hit this in advent of code, but this is kind of me working through what I knew was going to be a problem. Let me get it back here. So that was a scanner. The other alternative is a reader. And like I said, I never dealt with this stuff before, so I thought it was just useful to understand. So here's the reader doing the same thing, creating the exact same broken input, quote unquote, The thing about a reader is it's a lot more low level than a scanner, right? So it's designed to give you all sorts of, scanners always scan to a new line and they always strip the new line and give you, and you can do things to change that buffer length that I wrote in the earlier slide. But if you aren't sure what your input's gonna be like and you don't wanna have a giant buffer, it's probably better to do a reader. So this reader is uglier for sure than a scanner. You can see that it's got a lot more text to it. It doesn't read quite as well, but it gives you a whole lot more options of reading certain amounts or reading up to certain points. So in this case, I'm reading up to the new line, trimming the new line off because it's putting it out. And if we do the playground here, I don't know why I have to maximize that. Then you see I actually get that giant 4 thing without having to change my buffer at all. So this was just, I took this opportunity to learn the difference between those two because I had a vague recollection of what they were, but I hadn't really gone into it. So that's kind of cool. We'll move on here. This is what I ended up doing, and I use this encode parser for all my encode for the rest of advent of code. And it did use a reader, and it just reads up to the first comma, and then never, I don't have to worry. My encode input could get as long as it needed to be. I never had to worry. Did you ever have problems with? Did you always copy and paste all of your encode into your Go code?
Yes.
Okay. You didn't. Did you use it?
I didn't find any problems, and that's why I thought that was interesting. Like the big one at the end, the 25 one, the longest one, I put in a file and it just worked.
Okay, so maybe I'm just being super paranoid. This might be my sysadmin, have 3 copies of everything, everything is gonna break eventually, but I was like proactively assuming that the lines are gonna get crazy long, and
It did.
yeah, they did, but never, I mean, the buffer is pretty dang big for a scanner, but it's nice to know that it will fail silently. If nothing else, you take away, check the scanner error when you're done with the scanner to make sure it's actually done and not broken. Whereas the reader, you have to check the error yourself and exit on an end of file, so you always have to check the error in a reader. So it's kind of in a lot of ways it's better. Day 3, more parsing ephemera. Day 3, you're given a file with a bunch of lines, and each of those lines contains something like in this first line here, something like R8, U5, L5, and they were instructions of they were diagramming wires, and the wires started at a 0 point and then went, in this case, right 8, up 5, left 5, and you had to find where they intersect. Again, I've done a lot of glue code in Go, so it was interesting to me to parse out these strings into a deeper struct and then operate on that struct. So what I ended up doing is runes. And I know that runes exist, but I've never really, and I've used them, but I've never really thought about them too much. This is the function I end up using to basically take something like R75 and return a instruction that has my direction and my distance parsed into types for me, so I can do further stuff with that. Something I learned that's really cool about runes, runes and strings are both technically byte slices under the hood. All strings are byte slices, and if you copy a string around in Go, you don't actually copy the entire contents of the string, you copy the pointer to the byte slice, which is why you can just slice, like you'll see here in the sint, and right there in the middle, I'm slicing the string to get everything past the first character. You can do that without having to string because it's already a slice, it's just handled in an interesting way. The one thing that got me with runes, though, if we go further in, is when I print them out by default, they become really confusing because the default stringification of runes is to give you the int, or the representation of the byte slice. So in my case, instead of seeing R, I'm seeing 82. And it can be hard to debug unless you have custom printers. So that was something that I had to deal with. I thought was interesting to know. This one was really, really fun. Day 4, you basically said, test all the passwords that are 6-digit long with 0 through 9, and find all the passwords in that range that match a certain set of rules. Right? Give us all the passwords that have 2 digits that are the same, and there are a couple other rules. I looked at this rule for 2 digits are the same and immediately thought, oh, I can use a \1 in regex and match anytime a digit is repeated. And that's when I learned that no, kind of like whenever you use regular grep without the -p flag, like not all regular expressions are created equal, and Go's are no exception. As soon as I put the \1 in there, I got this from the compiler, and it was really frustrating. And then I dug in further and found out that Go uses this thing called the RE2 engine, and I'm not a regex expert at all. And then we go further into their explanation of why they don't support back references, and it's an entire ugly thing. But essentially, RE2, and then when Go decided to use that, made the decision that there are no back references, there are no kind of weird parsing things, because there are things you can do with the references to abuse regexes and do denial of service attacks, either by on purpose or by accident. So they said, no, we're not gonna do any of that stuff. So it's a linear search. Something cool to know about Go, like if you're doing regex and you need that, you may need to use a different parser. Day 7 was another case of encode computers. All the other times that we used an encode computer, it was one computer for the entire Go program. So you didn't have to worry about having multiple copies of the memory of the computer. You didn't have to worry about multiple inputs and outputs. Day 7 was really the first time where they said, run 5 of these computers and do interesting things with their inputs and outputs. That became a theme later, but this was probably the first place where smarter people than me refactored their encode earlier on. It took me, honestly, till like halfway through, well past this even, when I refactored my encode to be a lot better. But this is basically saying, take 5 computers, wire the input of one to the output of the other, and then run them and see what the result is on the other end. Give one input at one end, let each of them process in turn, and then take the output at the end. And that wasn't too bad. Day 2 is where I thought things got more interesting. Day 1, you can kind of just run a computer, grab the outputs, and run the next one. You can do that in a linear way, just in your code. But part 2 says, okay, that was fine, but it's not good enough. You have to actually take the output when you get out of the last one and send it into the first one and loop through until they all send you the exit signal. And you could still do that, and all the Python people or whatever, I'm sure, just did that in for loops. But we're in Go, so I decided to do channels. And I found it really, really satisfying that with channels and sharing channels, I was able to wire the amplifiers together in code, like wire them. So this is what my amplifier type looked like, and the creation function is. So you give it the amplifier ID, a code that it's going to copy, like the int code that you're given as your input, and a starting input phase, which there's a whole thing in the problem for trying a bunch of different phases to see which one gives you the best output. The interesting thing here is I have this constructor now. I can make some amplifiers. So I'm going to make 5 amplifiers with the same code given a new ID. But the cool part is, let's go back. If you see, the input and output are both in 64 channels. So when it came to wiring each one to the next one, I literally, after they were created, looped through them again and said, your input channel is now his output channel, is now his output channel, and looped it back around. And so it wasn't me copying and pasting and starting the computers. I literally wired them by hooking the channels up together and making one input the other's output, and then looping through them all, starting them, and waiting for them all to quit. So that was like it felt like really, really natural. I've done a lot of Go code. I've done stuff with channels, and it felt really like a really natural way to solve that. I had some other problems doing anonymous funcs with channels, which we'll get into in a second, but I like that. Going back to runes, ints, and Unicode, again, I'm really low level, so a lot of my takeaways are about nitty-gritty type stuff in Go, because I haven't had to work with it. This is that same image that Todd was talking about, where you're given another really, really long line of basically pixels and what color they should be. And it could get infinitely longer, so I did another reader. And I read that line one rune at a time. So if we go over here, I created a reader, and then I would read, in a loop, I would read the rune, and if it was a new line, then we're done. But I had this rune that I needed to convert into an integer, right? I had a rune for 0, for the digit 0, and I needed it to be an int. And I Googled rune to int, and I got this weird thing. And it worked, and I didn't know why it worked, but it worked. And so I moved on, and then I came back to it later to figure out why it actually works. And it turns out, yeah, because ASCII is, the digits are ordered sequentially, you could basically just say, take whatever I have, subtract the ASCII representation of 0 from it, and I happen to get how many positions I am away from 0, which is my digit. And it does work, but you probably shouldn't do it. Because what happens, and I have an example here of the output, The first thing this outputs is 49, right? It outputs the ASCII of what 1 is. And then it outputs 1, the ASCII of 1 minus the ASCII of 0, which is 1. So 49 minus 48 is 1. But then if you put an A rune in there, that has an int representation, and the math will work out just fine, and it will print out 17. And A is not, I mean, depending on whether you're talking about hexadecimal and all these other things, A is, in my case, not 17. So your logic gets silently corrupted if you ever send it a rune outside 0 through 9. So what I probably should have done was this second part here where you stringify the rune, and then you do a string conversion or string to integer, and then you can actually check whether or not you got a failure. So you can see in the example output here, 1 will still convert the way I expect it to, but if I try to send it A, it will error out on me the way I expect. So kind of I did it, and at first I thought it was some sort of Go, like black magic, and it's not, just ASCII stuff. I agree with Tod on Unicode. It's really nice to be able to just put in the /use in Go and get your Unicode characters. It made reading that image a lot better. And I've mostly put this in here because you notice you've got solid blocks and shaded blocks. It took me an embarrassingly long time to figure out why I couldn't find a Unicode character anywhere for an empty block. Stewed on it, and I stewed on it, and it wasn't until a different day where I wanted an empty block character that I figured out what it was. It's a space. So it's like classic over-engineering is like, there's gotta be a Unicode character for empty space. It was right there. This is a warts and all talk. Day 5, we did some more, and I know that we're doing a lot of encode here, but day 5 did some more encode. And by the time you get to day 5, you have still, your input is just a list of integers separated by commas. That's all it ever is. But suddenly those integers can mean all sorts of things. Now you have to take the integer that's your operation code and split the integer up, and based on the position of different values, it'll actually change what the subsequent integers in your operation mean. They no longer mean positions. Sometimes they can mean literal values. So what we've got now is, inside this list of ints, I've got 3 kinds of integers. I've got values, operational codes, and parameter modes. You could just pass them around in your code and call them integers everywhere, and it's fine. I did something that maybe this is not a surprise to anybody. It's not a surprise to me. I like it, so I'm pointing it out. Was doing custom types over the built-in types. I mostly stole this from, I do this a ton in Kubernetes and Client Go, where anytime in Kubernetes you have a YAML and you have a key that could be a defined list, they always do a custom type. They never just have it be a string. They always have it be, a mode that is over the top of a string, so that you get a lot of compilation checks. And so I did that here, and I think it made much more readable code at the end, right? Because my opcodes are no longer ints, they're opcodes to the compiler, and I catch more errors. Same thing with the mode, just makes it cleaner. If no one's ever done this,
Never use IOTA, it's the devil.
I've seen it, I've never used it. I thought maybe I should.
Zip stuff.
It just,
Yeah.
you could say IOTA and it would
Do the
number
zero.
them down.
Do not look at my code. Do not.
Well, the
Do not
problem
look at
is,
my code.
it wouldn't work for this because the bottom one is 99. It's not even sequential, right? So, oh, really?
Stop using IOTA.
Okay. I don't know. So,
But then all of a sudden the order of your variables matter. And if someone comes and edits it, everything is broken.
that's a fair point. The other really cool thing is you can do methods on custom types when you define them. You can create a method that takes your custom type and prints it out, or does whatever, just like you would on a struct, which is really, really neat. I don't know, again, maybe this is kind of where you get a little bit of that Python, like everything's an object if you want it, but it's only if you want it to be, which is a cool thing that may or may not be unique to Go. Day 11 was, again, not a Go-specific thing, but kind of a revelation for me. Day 11 is the first time that you do some stuff and you end up with getting outputs from a process that represent a screen that's so many pixels wide and tall. And it had always bugged me. I'd done stuff with graphics libraries before, and it always bugged me, why is the top left 0, 0 and the middle not 0, 0 on every graphics library you use? right? Because we're all taught Cartesian coordinates and that 0, 0 is in the middle and you go, y gets higher as it goes up and goes negative as you go down. And then you do it in code and all your graphics libraries, 0, 0 is in the top left and y gets higher as it goes down, which is really weird at first. And then x gets higher as it goes over and there are no negatives. And it wasn't until I did this that I'm like, oh, because if you're gonna print pixels in a row, you don't start by printing them from the middle and then like go out in multiple directions. You start at the top and go left to right. It's also really weird because when you represent it this way, if you're not doing any, I was just doing it with raw slices, the y is always the first coordinate, not the second, right? We're used to doing x, y coordinates in Cartesian stuff, but if you do it raw, it was always the first thing. And not a Go thing, it was just kind of like, oh, yeah, that's why. It's because it's hard to print from the middle. The other is day 13. I made a challenge for myself when I did this to not use any external libraries. So I didn't do any image rendering libraries. I didn't do any raw terminal emulator libraries. And so day 13 was run an encode computer and it's going to print out what was it? Not a Pong game, but it's Arkanoid.
Atari Breakout?
Yeah, Breakout, thank you. Going to print out a Breakout game, then you play that game or program it or do what we did and hack the game to just not ever break. And my default thing was to just print the whole screen every time and just fill up my back buffer infinitely with every single frame. I found this kind of cool. You print out these magic bytes and it basically emulates what a clear screen is. And I mostly brought it out because it was kind of neat to watch. So this is what it looks like. This is, I know there are like raw terminal emulators in Go, but I did actually a surprising amount of things this way, where I just clear the screen and reprint over and over and over again. Again, not a Go specific thing, there are terminal emulators out there that will give you raw access and let you just print to specific places.
There was one left. No, I'm just kidding, you're not doing it.
The problem is the fewer there are, the longer it takes because it's just pure random. So it literally just is running until they're all done. This is actually somebody at Weave that said, if you tell your encode computer when you get the quick code, just don't. It'll not exit the program and you can let it keep playing itself forever until it's done instead of having to actually write a solving algorithm. So I did that. 21 and 23 is fun with functions. I did the same thing. I actually did channels for my, as you said, I did channels for my input and output to all my computers initially. And then Todd pointed out you should do first class functions exist, which I forget about in every language that has them. Like Python has them, JavaScript, that's kind of the only way you do things. But Go has them and I forget about them a lot. And they're incredibly useful if you remember that they exist. So I defined some input and output func types. And I did something like this in a lot of my solutions where I created a new computer and I passed anonymous functions in so I didn't have to define them up higher and use them. But I hit some weird problems with this. And I have a contrived example to illustrate this. So here's where instead of just creating one computer and running it, I'm creating n number of computers and then running them all kind of concurrently by threading them all. And I had problems with anonymous functions, and I'll kind of get into that. Here's my contrived example where we're going to print 0 through 9, right? We iterate through, we print 0 through 9. This is not crazy code. Now, if we want to thread this for whatever reason, you would use Go, and you'd spin off a function, in this case, another anonymous function, and say, okay, well, I'm going to want you to go print 0 through 9, and nothing happens because the program exits before your work can be done. This isn't a super surprise. I'm mostly pointing all this out for the things I learned that I did hard that I didn't need to do. So you do what I do, you make a done channel that you spin off, and then you just have them all signal when they're done, and they're printing out, and then you wait for 10 signals to be done. Like, this is a raw way to do it. This is not how you should do it. This is a way. But then I had this problem where I just got 10 over and over again. Not even 9, 10. And if you use GoVet, it will tell you what you did. Like, the compiler doesn't care, this is fine, but GoVet will warn you about the stupid mistake that I did. And the mistake is right here. if you let your anonymous function slurp up a loop variable, then it's going to change constantly as the loop goes through. In fact, let's go to the playground to see how that works.
So looped through 10 times before any of the go functions were finished calling, right?
Yeah, it went all the way through. It even did the last I++, and then the memory that was left had a pen in it, and they all it's.
Well, it's worse, the parameters are not evaluated until that go function runs, which is way after your loop.
Oh, so yeah, so and it's easy enough to just not realize what you're doing. So do this. Go vet, which is run by the Go playground by default, will tell you like loop variables captured in there. They're like, it's really nice to be able to do that sometimes. Sometimes it's amazing that you can just have a function that you define and pass it something without having to make it a function argument. I've done all sorts of silly stuff like that, and it's been fine, but not with a loop variable. It's going to be constantly changing each time. So yeah, like I said, it's evaluated when the go function executes. Not if you do, we'll go back. If you do want to have it evaluated,
function key.
well, thank you. So the final thing that I came up with as the contrived example, and I'm not going to go into the details of what my computer did wrong, but it was a combination of these kinds of things where I was defining anonymous functions and not really understanding how they worked. But if you want to do this the right way, instead of passing I in here, you actually pass it to the function, take it, and then it's evaluated at this moment when you first spin off that function rather than when the function runs. So if you do that, it'll print out 0 through 9 in some sort of randomized order. And that was the other problem I had is this specific day wanted you to find the, 200th thing that happened. And that's kind of against the entire point of spinning things off in Go routines to have an ordered output, like it works against it. So I did all that. And then I found out about weight groups. So I mostly just put them in here to say that you shouldn't do all this silly stuff that I did with channels and that kind of stuff. Like, this is a much cleaner way to basically do the exact same thing. I stole this straight off the Go by example, where weight groups will let you track all this without having to do your own channels. One last bit of thing before I'm done here is this thing that I love to point out to people. I don't know why I find it so interesting. Empty structs, 0 space in memory. 0. So you could make, in this case, my example here makes a channel, a buffered channel that has 10 spaces of empty structs. And if you calculate, there's no built-in way to get this with reflect or anything. I love it. But you can see that the channel itself is always just 4 bytes long because this is running on additive code, which is on a smaller architecture than my machine. But the buffer size for an empty struct is 0, whereas if I did it with bools, it's 10 bytes because each bool in the buffer takes a whole byte that has to be reserved. So it's kind of considered best practice. I've been doing this for a while without really understanding why I did it. If you're using channels in Go purely for signaling and you don't care about the output, then it's kind of considered common convention that you use an empty struct because it takes up 0 bytes of memory. It has no value at all to you. So it's kind of a signal to the compiler and to the programmer, like, this channel is for signaling only. I don't care whether the Boolean, you could use a Boolean, and who really cares about the memory for Boolean taking up, but it communicates a lot more things to use an empty struct. And it's just weird. They're 0 space in memory. So I could make that channel have 2,000 length buffer and it would still take 0 space in memory. So that's it. I will point out that I found this thing that I started taking a bunch of notes for what I want to do for the presentation. I was doing it in Markdown because I find it a nice way to take notes and mix up code and that kind of stuff. And I started spending way too much time on Google Slides converting my Markdown into slides in a pretty way. And then I found out this thing called Mart exists, which will take Markdown and just generate slides automatically for you. It even has a VS that is live previewing as you go through. It's like super cool. If you go in and you make a new slide with 3, you can either tell it 3 dashes is a slide, or I want you to just, there's some special flag you put in there that says just use the header hierarchy to generate slides for me. Anything that's a header bigger than this means a new slide. So you can actually just convert any markdown into a slideshow by default. So just something really cool that I found because it was a lot easier to make really, really nice, pretty slides with a lot of code in them. It'll auto expand the code blocks for you, all that kind of stuff. And that's it.
Any questions for Carson?
Well, I didn't steal anything actually on yours, but when I looked about day 14 at your repo and looked at your incomp, and I felt sad because you had like all these custom types, and I'm like, I am terrible. And then I just continued being terrible.
Yeah.
But I thought like I should refactor this, and then I was like, or I can go to bed.
Yeah. Anything I can get the compiler to check to tell me is wrong, I will do. Right? Like this. Thank you though.
Okay, so Todd excluded himself from the competition. So it was Jason, is that what you said it was? Jason got first place then, outside of Todd. Congratulations, everyone applaud for Jason. Jacob got second place, so 2 gift cards for you. And 1 for Carson. Applause for you're more than welcome to stick around, talk infrastructure or whatever you want to do, and stay as pretty much as late as you want. If you have any questions, feel free to ask. But I appreciate you all coming. Just take some pizza home.
Some sense?
No.
Yeah, instructors do for maps too. The empty instructor's good for maps. It's like, I just need keys. I don't need anything. I just need to.
I didn't think about that because I didn't.